Hello student. So today's session is on work, energy and power. So I have already few session which shared in my channel on work, energy, power, but today's session is mainly to increase your conception. Like work, energy, and this chapter is very important for ICSE class 10 and also for the class 11 students. And there are few concepts which are very useful and which are highly integrated in all other chapters. So you must have the concept clear on work and energy so that you can tackle all the problems like in your exams. And for class 10 ICSE students, you know that there is a dedicated chapter on work, energy, power for you, and class 11 students, maybe for ICSE, CBSE or other boards, you have a dedicated chapters work, energy, power. So this chapter is very important, and most important is that your thinking, like how much and which level you are understanding the chapters. That is very important because the different kind of questions are coming, maybe conceptual, maybe with some numericals. So knowing the concept is very important. So I'll just focus on the conceptual part of work done. So all of you know that work done means, it's an scalar quantity, it's a dot product of force and displacement. So W is equal to F dot S or Fs cos theta. Now, so first I will explain the relation between work done and the potential energy. Let's take this ball. So if I take the ball from this height to this height, so what actually I am doing, this ball is having a gravitational force, acting toward the center of the earth. So I am just, taking it off against the force of gravitation. So at this point, initial point, what are the forces? The downward force F is equal to mg acting downwards, and your displacement is on upward, like h displacement from here to here. So displaced in opposite direction of force. So angle between the force and the displacement is 180-degree, right? This is the direction of force, this is the direction of the displacement. It's a vertical, opposite directions. So they are opposite. Force and displacement are in opposite. So angle between force and displacement is 180-degree. So cos 180 is -1. So work done will be, minus. So it will be minus work done, minus Fs. So Fs is mg and S is the height. So work done W is equal to minus mgh. So this is the work done. Now you know that what is mgh? That is the potential energy. So you can see that work done and potential energy are acting in opposite. Like we are doing a positive work, right? From, so work done is negative here. If you see here, for this case, object is moving from here to here. So work done negative, and object is gaining potential energy from here to there. So it's gaining positive potential energy. So work done and potential energy, they are opposite in sign. That means when I am doing a negative work done from here to here, so my potential energy is positive. It's increased from here to here. So they are opposite in sign, right? So whenever there is an positive negative work done, means we are gaining the potential energy. Now next is that the object is here, it's coming down, we are reducing height from here to here. So what happened, the at this point force was acting downward, the weight is equal to mg, and displacement is happened in the direction of force. So work done is Fs, or F is equal to mg, so mgh work done. So it's a positive work done, but my height is decreasing from here to here, so my potential energy is negative. So positive work done means potential energy negative. I hope this is clear to you. Now, one more important, you have to know the conservative and non-conservative force field. So here the force is conservative. The potential energy concept exists only for conservative force field. So for non-conservative force, there is no such potential energy concept. Clear? let's say like frictional force and the viscous force, right? So those force are non-conservative force. Now the question is, what is conservative force? Conservative force means the force which is path independent. The force and the work done on those case, whenever you are calculating work done, so it's been force into displacement. That time, if the forces are path independent, then I'll be either gaining or losing the potential energy. For example, the gravitational height, we are gaining the gravitational height upward or downward. So we are doing work done, and also we are increasing or decreasing potential energy. So here the gravitational force is the conservative force. Electrostatic force, conservative force. Okay. So there are lots of conservative force like this. So one is gravitational force, which you must know, and electrostatic force is also conservative force. Next is the spring force. Okay. Elastic force, that's also conservative. So in this conservative force, you will get lot of questions. So here you can able to calculate the work done and the potential energy. Now next is the which is non-conservative. The frictional force is non-conservative. So there you are not going to calculate the potential energy. Now next is that work done, the force may be constant force, the force may be variable. So in class 10 we are taking the force as a constant, but in class 11 we'll consider the force as a variable in some cases. So there you have to learn the integration. So what happened? Work is equal to force into displacement. So force is variable means for every small change of displacement, your force is changing. So for every dx, if x is the displacement, for small change in displacement, the dx, so it will be f dx will be the work done. The dw means small work done for small displacement. So now if you are integrating dw, you will get the full work done. Okay, so we are applying integration whenever we are considering force as a variable force. Now next is that the force and vertical force displacement in the horizontal. So fx graph, the area within the fx graph is the amount of work done. So you may get question for that also, like if your x axis is this and this is the force axis, so fx graph, inside the graph area will be the amount of work done. So these are the concept of class 11, but I am telling you this is the ultimate, like you don't have to go more deep. Like if you can able to connect this part sitting in class 10, this is really very good. So you'll be comfortable to manage different kind of questions and reasonings. Okay. So you understand, I hope, the conservative force, the variable force and the constant force. Now next is the non-conservative force, means the this is path dependent, and work done in a conservative force in a closed loop is 0. Okay, fine. Okay. Next is the we understand the kinetic energy, that is the work energy theorem. The last part we have in ICSE class 10, or also this is the same part is repeating in class 11, right? So what is work energy theorem? So let's understand what is the physics actually. Like whenever we are hitting this ball, like or let's football, whenever the football is getting kicked off by footballer, or cricket ball is getting kicked off by applying a force. We are applying a force and this ball is moving. That means some work done is happening. Force into displacement. Okay, and what is the output? The velocity of the ball getting changed. That means the kinetic energy of the ball getting changed. So we are doing work done, and input is work done, output is the change in kinetic energy. So there is a relation. So that's the work energy theorem. So whatever work we are doing, it has a reflection on the energy. So we have seen the reflection in the kinetic energy. Now the connection in the the kinetic energy, like change in work done or amount of work done is equal to change in kinetic energy. Like initial kinetic energy for initial velocity u, the final kinetic energy for final velocity v. So change in kinetic energy caused by the work done. So this is the very brief about the work energy theorem. So you'll get question like, where the amount of work will be given. So the question will be that, tell about the amount of change of velocity or amount of kinetic energy. Okay. So this way you can go through, and behind this work is a scalar quantity. So force and displacement are two vector, they are in dot product or scalar product, they are producing work done. And the cos theta, value of cos theta, how it is rolling in a 360-degree. So if you have the four quadrant, right? So first quadrant, second quadrant, third quadrant, fourth quadrant. First quadrant means 0 to 90 degree, then 90 to 180, 180 to 270. So 0 to 90 degree cos theta value is positive, and from 90 degree to 270 degree the value of cos is negative. Okay, because cos theta means base by hypotenuse. So base, if x axis is the base, so left side will be negative. That's why from 90 to 270 cos theta is negative. So you must know this so that you can connect the physics. Okay, so this way you have to go through, and if you follow my session, if you go through this session multiple times and just spend 5 or 10 minutes and think on this part, I think that will really help you to manage different kind of questions. Okay, thank you, thanks for watching my session. So I'll be releasing so many sessions, like where you'll be really focused on the conceptual part. And if you like my session, please subscribe to Chatterjee Academy channel. Okay, thank you, bye.